Hey everyone, so our next talk will be about breaking web3 bridges and burning out any web2 hacker. The talk will be from 6, and yeah, enjoy.
Thank you. Thank you for having the opportunity to present here. This will be a story about web3 hacking, especially focusing on bridge hacking, what kind of hacks we saw in the past, and some interesting techniques which I presented in the past. And how web2 hackers come into the picture is because in InfoSec conferences and the info security community, most people are still living the web2 era, and we are only a few who are working with web3. So I think that we really need to raise awareness on this topic. So I just quickly introduce myself. That's the least interesting part. I'm doing security research and architecture for web3 systems, mostly systems that are focusing on development related to Solidity and Rust substrate. So I received some really funny feedback for my workshops when I was presenting in the InfoSec conferences, which you can see that some people were like, oh, how does it work? There is a void in my head about Web3. I feel like a dinosaur because they do not know anything about decentralized communication, how the nodes are connected, what EVM is doing, and so on. So for you who are here in this hackathon, I think you are in a really good position now that you are working on something really new, something really innovative. So I really hope that the techniques now I show you will give you some inspiration and help you on working in really cool projects. So that was the simple topology I showed to the hackers at the workshop. I suppose you won't have issues understanding what's going on in this bridge setup. So basically we have one chain which is an Ethereum-based chain, and the other chain is a substrate chain which also has EVM inside. So in that there are the Solidity smart contracts. The tokens are wrapped on both sides, and there is a bridge that connects them together. So what can go wrong? Actually, many things can go wrong. In the workshop, I let people guess it. But now, since this is only a 30-minute talk, I don't leave so much time on this. So we will start with some examples on what can go wrong specifically for the receipts. But to get there, we need to know how a transaction works. So I always present this part at the workshops. If you want to see all the small steps, then you can refer to my Git, which will be in the references of this presentation. Because what we are doing is basically playing around with the signatures. So that's how we will get to the ECDSA forgery. And now we are going step by step. So the warm-up technique, this is the most simple, and why I introduce this kind of simpleness here is because what I saw in the bridge hacks, it happened many times that you don't really need to be advanced. You don't even need to read the whole source code, understand what's going on, and audit everything. You just use Etherscan and start calling the functions, and you might be lucky because something's left uninitialized or someone set the wrong visibility, and this is still working in 2022. So this is, I think, something if you are developing, you still need to be very careful about the basics. If you miss the basics, then you will still have a lot of issues with security. So the first one is an example I like to come up with is the web2 hack, because this is a very straightforward example. There are very good write-up on the website, and this basically totally matches the topology which I just showed you. So what was going wrong with the receipts in that hack is that there were two chains, two smart contracts, and they were not checking that the receipts were used on the other chain. So you basically sent the coins to the bridge gave you the receipt, and you could use the receipt on both chains. And you wonder, how could someone miss this kind of vulnerability, and how could someone, not think about this? And that's most probably the reason behind this is that when you are creating something new, you are implementing your own bridge, you are implementing something innovative, then you can't think about everything. And when the issue came out and the guys saw that the coins are being drained, they had to spend a lot of time figuring out how is this possible? Did cryptography go wrong, or what was happening? And then it turns out that all that was happening was going through the mint with received function. And the funny thing behind this story is also the attackers were really quickly found, because they were like totally newbie guys asking on the Telegram chat, so we even have the Telegram logs, that the two guys were asking, how does the bridge work? How can I copy the receipt and play around the system? So basically the attackers were asking the developers on how to hack the system. So there were some signs in that case. So that's a funny story, but that's something that we can still see happening on the scene, that we have this kind of replay type of attacks. And that's why I called it like TRDR or TLDR, that I didn't even read what the smart contract is doing, but still I can hack it because I can get lucky, or as the developers. An even more interesting topic is the signature forgery, which I brought to you. And this was basically part of a CTF challenge. We always organize a CCTF, which is a cryptocurrency and cryptography hacking challenge series. And in the last one, we introduced the decentralized CTF system, where we wrote our own smart contract, so you don't send your CTF flags to CTFD. By the way, please raise your hand if you played CTFs before. Okay. So I explained a little bit about this, because I see the majority were not playing CTFs. That's a capture the game flag, where you have a challenge set. So let's say I give you a binary, and there is a hidden string inside the binary. You need to find this and then submit it to the system. One of the most common systems that is used for this flag checking or submission system, which gives you the scores, is CTFD. That's like a standard front-end, back-end kind of setup. So what we did is that we implemented a Solidity version of this, and we added some ECDSA trickery behind, and created a hidden challenge there. So what was the challenge? First of all, the players had to figure out how to submit the transaction. Funny statistics, we had 100 players before who were able to register on the web2 front end, and when we introduced the Solidity version of that and didn't give a front end for the people, it basically cut the player number to 25. So that was also funny statistics, though we didn't care much about this because we wanted to make sure that the players who are playing the CTF are actually capable to send transactions, because our aim is to create a game for those people who have at least their skills. So after this, you had to find a flag from the challenges, and the flags were actually private keys. So what you found in the binaries, in the smart contracts, in whatever, you found private keys. And with the private keys, ECDSA, you can sign with the ECDSA keys. And this is something you can send to the smart contract. So I'm not sure if you see this right or clearly from there, but what was going on? Oh, nice. I have a pointer. So this was the submit flag function. So what was the trickery here is that we first check the basic things, that the player is verified, that the message is not too long. We implemented some features against reusing the same flags. So we check the nonce, which is a really common practice. But still, that is not enough to protect the system if you verify against the address. Because when you sign a message and you send the transaction on the chain, first of all, everyone can, of course, see it, but the data you send and the VRS parameters of the signature you create can be used to create another signature that will be verifying that the address is the address that was originally sent. So this is actually how it's working in ECDS. It's not a bug, but it's like a feature, and it's normal that it works like this. Not too many people know about that. I mean, cryptographers, of course, know, but there are not so many cryptographers in the world, and there are many more people who are implementing systems that are using these types of logic. So you might have figured out the challenge from this code already, and that's we are just only checking the address. And then if the address matches from the flag owner, then the code goes through and you get your point. So this was the example we implemented in the CTF. Basically nobody found it at that time except one guy. So that was, oops, sorry. So that was SI. We never say who that is, but it's SI. So it's thanks for him, because he wrote a really nice article as well on this, and how the math works behind, and all the details. So if you want to check out the proof of concept code, then you can go on my Git and check out this repository and see all the details on how to create your own forged keys. And of course, Bitcoin is also using a similar theme. So basically, you can do it with Satoshi key as well. You can prove you are Satoshi, at least the address. You won't be Satoshi, of course, but you can kind of forge or not kind of, but you can actually forge a signature which shows that the signer key is Satoshi key. Of course, if someone tries to recover the message, that will be an unclean message, because you cannot create like valid messages. It's more like some random message that will be verified as Satoshi. So a reminder here about the non-Web3 hacking. So we saw something very simple with the first example, that you just basically send the same transaction data on another chain and double your tokens, wrapped tokens. And we saw something more advanced, which is the ECDSA forgery. And here is a reminder, because we still have a lot of systems that are not fully Web3. We are not in an era where everything is fully decentralized, totally transparent, and we see most of the projects that want to create something useful, they just introduce some web2 functionalities and features. The systems are also running in standard servers, standard Linux, and sometimes, unfortunately, Windows servers. So this is still a thing happening, and if you can get web2 hacked, then you will still see and face the same issues that we had before. And XC hack was a really good reminder, because that was not a web3 kind of very new type of hacking. It all started with all the web2 techniques, which we did in 2010 and even earlier. So there was only new regarding the 51% attack. And of course, we have more fun techniques, which is social engineering, and all the social engineers love how MetaMask handles signatures. One of my friends has a really good and extensive talks on how you can trick the MetaMask users and how you can create front ends and tricks to steal all the tokens and coins from someone. So if you check out the Hacktivity talk of ZHack, then and not just the Hacktivity talk, but also the Hack in the Box presentation, Hack in the Box Singapore, we were there together. He was presenting that kind of MetaMask hacking and a lot of tricks on how to social engineer MetaMask users, while I was presenting something similar like you are hearing now. Hopefully, if you play with that, you do better than that. I just left it there as a joke, because not all the attackers are advanced, but still succeeding. And the future price prediction, I just left it there as another fun slide and a good reminder that I really hope everyone is more interested in building something good, something that helps the ecosystem, and that's my personal experience. If you are building something that you really like to build and you really do it from your heart, then crypto will welcome this and help you succeed. If you want to dump the price, then crypto will dump you as well. And conclusion for all this, and I guess I'm still in the 30 minutes. So, yeah, we are in a highly experimental environment that is forgotten by many more like project owners who are like, you know, pushing the development, and they want us to get ready with everything and make it happen really quick. But still, we have a lot of news coming out, a lot of new technology that is related to blockchain, Web3, whatever we call it. We are just connecting the chains together. We have just kind of invented the bridge systems. We have XCMP for only a couple of years and is getting used, XCMP, the cross-chain messaging protocol. So that's something that is right now becoming, and I wanted to raise awareness on this thing that we need to handle all these things how it is and not how people imagine. Because we are not at the point where Web2 is. We already know SQL injection, XSS, and all the vulnerabilities. We don't really see many new Web2 hacks or types of Web2 hacks coming out. And we are very far from here. We know a lot about solidity hacking. We know the most common issues, but still new things are still coming out in a really fast-paced world. So probably you want to make sure that when you deliver something, that this should be handled like that. And I think transparency and awareness is a key solution, or maybe not the solution, but key concepts that the development and how these things are being developed and worked on are communicated to larger audiences, and no one is waiting for something with a big hype that is not there yet. Very good example is the metaverse. Everyone wants to be on the metaverse, but when I asked the audience about this in my previous talk, who was in the metaverse, there were like a couple of people who enjoyed the metaverse. Nobody enjoyed the metaverse because it's not yet there, and it's not, except a couple of projects that actually delivered something useful on collaboration, but that's another hackathon. So yeah, and just a joke down there by my audit services, you don't need to. Just joking. More importantly, good luck and have fun with this hackathon. I hope I inspired you a little bit. If you want to contact me or find the proof of concepts, the code, and all the details of what I just presented, then you can find all the links on 6thedave.me, my Git, and also GitHub, which is a backup only. And you can use the QR code. This talk slides, it's also on the Git, so you can find the links and check out everything from there. So thank you very much for listening. That is what I was preparing. Do we have a Q&A part now, or we just get to the next speaker? Oh, okay, so I was faster than I was expecting, okay. Do we have any questions? Yes? Okay, microphone is coming.
Have you found any big bugs, like on mainnet? Or on
mainnet, Ethereum mainnet?
Like on a bug bounty program or something?
Like generally, or something that I reported? Like there are many bugs. Yeah, sure. There are way more things uncovered than you would think. And even in smart contracts that doesn't have the source code out on Etherscan. That's also a really big pull if you are looking for some nasty things, that you are looking for smart contracts deployed that doesn't have the source code, and you reverse engineer them, you can find many interesting stuff. Yeah.
Yeah, but I was asking if you have found any.
Yeah, sure.
Sure. Yeah, but can you share some like bugs that you have found, like, or are they like private?
Most of them are private, but I can share some examples, or if you want, I can explain re-entrancy attack. If you want to have some bugs explained, then I'm happy to do so. So, yeah.
Okay, yeah.
Like I'm doing security audits, so if you go on my security company websites, most of the audits are done me, so you can see all the lists of what we found. And of course, if it's Solidity, we found everything from re-entrancy attack, overflows, and logic bugs. I'm more interested in logic bugs, actually. So the more interesting parts are when, you know, there is a business requirement coming, and the developers think differently, and they implement something else, or make an arbitrary calculation in the math on how the prices are calculated. Like recently, we had a finding in a project where there was this kind of miscommunication, and when we checked the minting function, we found that the prices were like totally different, and what the marketing was communicating, that there will be X and Y amount of percentages, and the staking will be X and Y after 1 year. That was like totally different. That's something which, from developer point of view, this is something you might not notice. So,
yeah. Okay, nice. Thank you.
You're welcome.
Are there any more questions?
Maybe, is it? Yeah, I think it's work. Maybe, I don't know if it's like a question is fitting in the topic like that, but do you know how it is solved on layer 3 with bridges? When they're like separate app chains, let's say, and how the bridge looks like that. I'm talking more about like layer 3 on Ethereum than others.
Well, I'm mostly familiar with the Polkadot ecosystem regarding bridges and these type of systems. I know that we have a lot of news coming out regarding that, and especially I think what is interesting, if you are looking at atomic swaps, or if you are looking at the zero knowledge solutions. I recently read some white papers and some proof of concept code during ZKP, but I'm pretty sure that this is very early stage right now, And again, this should be like considered as something like experimental on the stage, because if you go out like with most of the projects, then there will be problems coming out. If this answers your question, then.
Yeah, sure. Thank you. And maybe one more. I'd be interested how to do how we can use a Bitcoin, for example, in Ethereum, in a smart contract, but in a more like a secure way than it is usually claimed to be. Because when we consider using Bitcoin in some smart contract, it is usually said that it's not really safe. So, is there any way how to really do it safely?
Mm-hmm. I wouldn't say safely or securely, because I think that we are far from this being tested out, but basically what we see right now is that with Substrate, I'm pretty sure that we have solutions for this, and we are using, okay, who knows Substrate? So if I should like, okay, cool. Okay, oh, more than I was expecting, really cool. So in Substrate we have much more ways to handle private keys and use advanced cryptography than what we have in Solidity. So I think for the cross-chain solutions, or swapping Bitcoin to Ethereum, whatever cross-chain or multi-chain solutions, we will need the Substrate ecosystem and have something implemented there. The latest project I saw that is doing this, oh, then what was the name? I will check this out and send it to the chat, but I just saw a new paper that was in the end also funded by the Polkadot ecosystem, and they are implementing exactly what you are asking on top of Substrate with ZKP and some private key trickery. And also what's very interesting in the ecosystem is the OCV workers, I think, because this can also be utilized in some ways to solve this issue, because you need to communicate with the Bitcoin chain, you need to somehow figure out how you sign a transaction, you need to collect that amount somewhere, which now we do it most of the time with the bridge systems. So the question is, where do this coin go, or how do we solve this? Or if we use some cryptography trickery or threshold ECDSA, I also saw threshold ECDSA used in this scenario, but the problem with this, then the first papers came out, everyone realized after a year that, oh, there are like big issues with that, so we shouldn't use that. So again, experimental, but yeah, it's definitely coming and it's on the way. I don't think Solidity itself will be enough for that. We need some other outside of Solidity solutions.
Okay, thank you very much.
You're welcome.
Hello? Okay, so my question would be, which tools do you recommend for auditing your own smart contracts? And specifically, if it's worth paying for consensus mithril, or there are better options in the market?
Okay, I recommend the best tool, which is yourself. Start with reading the code, understanding what is the intention behind the code. Check the requirements that were set against the code. When you do a security audit on a smart contract, normally you should receive a list of how this should be working and how this will be deployed, because you should be doing the audit before the deployment, and you should be doing something that is very, very similar what will be running on the mainnet. So that's the definite start. Most of the time you don't really receive much or anything, so you need to figure out yourself. So that's the first thing, that you need to be like understanding really well what's going on. And then second step, you can use automated tools like Slither, Manticore, Octopus, whatever, and some symbolic analyzers. But to set them up, again, you need to understand what's going on, otherwise what will be set up. So especially for symbolic executors, you need to understand the logic, because you most probably won't have 100% coverage of the tests. Because when someone sends you a contract for audit, it's probably something non-standard. It's kind of rare when people just, okay, here is this ERC20, just audit it. Those projects that are doing this are often doing it with some not actual security auditors, just putting the logo on that. But for like real big projects, you need to understand what's going on. And yeah, it is very helpful to emulate the system and run tests. You can also do some fuzzing, even though I'm not a big believer in Solidity fuzzing, but there are also tools for that. If the question is for Solidity, that's what I was expecting.
Yeah, it's for Solidity.
Okay.
Thank you.
You're welcome.
Are there any more questions? Yeah.
Hi, thank you for your presentation. Maybe can you elaborate a little more on how you find bugs in unverified contracts?
Mm-hmm. Yeah, so on the unverified contracts, that's actually Octopus, which I refer to, is a very helpful tool. So what you can do is to disassemble and try to see what kind of functions exist. So first, recommended thing is that you figure out the functions and what parameters they take. You might find out that like 80% of the code is already something that is deployed somewhere else. Even on EtherScan, there is an option that you can check if the bytecode is similar to something else. So you can do that. You can then well, if you are in a state where you figured out it already exists, then you have a really good way to figure out the issues. If it's like standard ERC20, which has been deployed 1,000 times, then you figured out that it doesn't worth much to look into more. If you find the custom parts in the code, then you can start the more interesting projects. Based on the function name bytes, you might have the chance to figure out the name. There is a database, 4bytes.dictionary or dict or something like that. You can look this up, but I think I have it in the presentation slides somewhere in the repository. So you can look up the function names and then, yeah, read assembly and try to figure out the logic, what's going on. Radar2 already has some plugins. I'm not 100% sure that right now it's working, but Radar2 has like a reverse engineering plugin for EVM bytecode. So that's a tool you can probably use. And the guy who implemented it, I think he will be there tomorrow if you want to get deep into that. Yeah, you can catch some patterns, like reentrancy patterns. If you look at the Slider rule sets, you can take some ideas and look for them based on the assembly code.
Any more questions? Okay, if there are no more questions, thank you. Oh, sorry.
So the talk is about bridges, and what's your view about the bridges are kind of centralized because there's like one computer running, so everything is running from one chain to another on one computer. So what's your view on that, and if you think that in the future is going to be like a specific chain that works as a bridge, for example, like decentralizing bridges?
Mm-hmm. It, I think, comes back to an answer which I gave previously, that I'm pretty sure we already have some solutions for having these non-centralized bridges. I think this centralized single point of failures should be going away at some point. We still don't have much more stable solutions. But yeah, I think this needs to be replaced definitely, and basically the research is going on in these topics. So to stop this kind of web2 hacks and to transit to an actual web3 system, we need to solve this. Otherwise, that won't be web3, and we haven't spoken about anything like user friendliness or performance, just the pure technical solution. That's still not there, but on the way. In the Polkadot ecosystem, we already have Polkadex and Interlay, which is doing swapping in a mostly decentralized way between DOT and Ethereum, and it's not like a wrapped token, it's like an actual solution. But that's still more experimental.
Thank you.
You're welcome.
Any more questions? Okay. So if there are no more questions, thank you for the talk, Six.
Thank you.
So the next talk will be in like 20 minutes, so feel free to grab a coffee or some cold beverage at the bar.